Hello. Good day. Oh my god. Um, it's been such a rough week. My brain hasn't been working. Our youngest has been sick. He's still sick. And yesterday, like him and I were supposed to have like a guys' weekend as my partner and our daughter went on a girl trip. But yeah, like he slept like 16 hours. We had to wake him up, which sounds great, but it's not really great because, yeah, he didn't like recover, just sleeping all the time, not eating, not drinking. So, yeah, I spent the evening yesterday, the beginning of guys' weekend at doctor's for almost 3 hours. And then, yeah, waking up in the middle of the night, still not feeling well, have to get a prescription, and they didn't have it at the nearest pharmacy, so we had to go back and drive the car to some other pharmacy. And oh yeah, I just need to complain. But in the midst of all this, I've been thinking about let's see. I've been thinking about something, and let's look at this from the perspective of React states first. So, what is like the responsibility of a state machine? Because you really have two different concepts. You have this thing called a file, and I'm not like an expert in the academic theoretical stuff. So you have to take what I say with a like pinch of salt. Is salt? Yeah, is that the term? Anyways, but you have finite state machines, which is very basic. They're only about managing some piece of state related to events coming in. It doesn't deal with side effects. It doesn't even have like nested states or anything. It's very, very basic. And then you have state charts, which is like this much bigger concept. And there you have like nested stuff, parallel states. You have actions and effects. Like you have a lot of concepts in there, which is what you need to actually do something practical. I'm not sure about the boundary here. Like, there's a long way from a finite state machine to a state chart. And where does like React states fit in? Because you can get so far with a finite state machine with a couple of tweaks to it. And I think that's important. Like when you, because it holds like the core principle of these explicit states. And to take advantage of it, it's better to start with like a finite state machine concept than a full-fledged state chart concept. And this is what React states tries to be. It tries to be as close to a finite state machine as possible, but and instead of kind of like in a state chart, you will actually reference what actions to run and everything within the state chart. But in React states, you don't actually define that. It's still closer to a finite state machine in the terms that it only deals with state, but you rather react to these state changes from the outside. So you kind of subscribe to the state machine, and then you run side effects related to what's happening inside the state machine. So the state machine itself doesn't know about the side effects, which you can argue in one side is like a good separation of concern. But on the other side, you can't like look at the state machine in isolation and see what it does. And the thing that has been the most difficult concept is, one thing is having side effects related to actual transitions to one state to another. But where it's become difficult in this, like, is it a finite state machine? Is it like more towards a state chart? Is when you want to run a side effect without transitioning to a new state. That has been the most difficult thing. And the current concept has been these commands. Do we have an example of commands? Well, basically what you would do is, so that's one thing. It's like that concept of actually doing a side effect but still being in the same state. And this ties into reducers as well, because in a reducer, you don't subscribe to a reducer. It's not like a state machine object. It's just, you just have the state object. So the only way to produce side effects is to change that state object. But the state object itself is supposed to only represent state, but then how do you keep it in the same state and run a side effect related to that? So what you have to do is, so one try was to use commands where you actually attach a symbol. Like, I should have an example of this. Let's just go on GitHub and look at an old version of React states. We can look at the main version. Let's see, API, use command. Yeah, here we have command. So you would actually allow attaching a command to the state. And then to run that command, you just attach it to the return state. And as you see here, it's in the same state. It makes sure that the reference changes, which it kind of has to when you attach a new property. And then that is used as an explicit side effect. But now we're in this, like, should that actually be the responsibility of the reducer itself? Should the reducer actually care about this command of saving data? Or should it be just like the other side effects of transitioning to a new state? Should the transition of going from loaded through the action add item back to the state loaded, should maybe that be a side effect? Like, you interpret the machine from the outside and then you run side effects related to that. So the reducer doesn't know anything about saving data. It just knows that if you're loaded and you get an add item action, you should return the same state. That's all. And I'm having a hard time deciding on this, because what it results in is that instead of having a use state effect and having a use command effect, there's just one effect. And that effect is called, I don't think I even documented it yet, but it's called use transition effect. And what it basically does, where the hell is the DevTools? There we are. What it basically does is, oh, we can actually remove this now, is that the use transition effect, so the previous use state effect allowed you to like point to the state, and you could either say, when transitioning into idle, do this thing. Or as you can see below, you can say, if you transition into idle or foo, run this side effect. And when you transition out, like when the state is no longer idle or foo, run the disposer. And then we had like use command effect. Use command effect, which is like the command symbol and everything. But what I thought about, what if we just call it use transition effect? And you can express that as transitioning into a single state. You can express it as what I just said, when you're within these states. Oops. Or what if you could say, when you move from idle to foo? So you actually have 3 signatures, where all of them is about interpreting the machine or the state changes. And what you can see down here is when I use a transition effect on the resizer, saying that when it moves from resizing to resizing, go and trigger the callback for on resize. That makes a lot of sense. So unlike the use transition effect of resizer only resizing, this is when you move into the state, right? So if you were to move from resizing to resizing, this wouldn't trigger again. It's when you enter the state. While this is more of a low-level transition effect, where the only constraints is like when you're moving from to specific states. But it doesn't matter if you're in the same state, it will always trigger. And then we have use transition effect on detecting resize. So when we move from detecting resize to idle, that means that we want to trigger our own click. It means that we were mouse down on the resizer, but we didn't start resizing, which means we want to treat it as a click, which collapses the whole dev tool. So this is interpreting the state changes as side effects. And in these two cases, it makes a lot of sense. Like it smoothens up the experience. You don't have to understand commands at all. You just have to understand this single use transition effect, which is super powerful. Now, as I said, in these two cases, it just makes perfect sense, at least in my mind. But if we were to move to the demo thing here. Okay, so here we have a reducer. Oh, I haven't cleaned this up. But here we have this thing where we are fetching some data, and when we are loaded, we are allowed to add a new to-do. And what we do here is that we do add the to-do to the to-dos. Yeah, actually here it does make a lot of sense. Okay, so what we're doing here, we're just updating the state, right? Adding the to-do, moving back into loaded state. And the transition effect we do here is that if we move from loaded and back into loaded, the first argument here is the state we moved into, which is loaded. And the second is whatever action made that transition happen. So when I have what state did I move from, what state did I move into, and what action caused that transition to happen, then I can start doing a lot more powerful stuff. So I can say, okay, if I move from loaded to loaded, and that happened because I tried to add a to-do, I actually want to save that to-do somewhere. That's a side effect of updating that state, which makes a lot of sense to me. Yeah, it actually does. And then the whole command concept is gone. It's the only thing you do is that you make your state changes happen inside your reducer. It's only about guarding states. And then you use the transition effect to cause any kind of effect. It being entering a specific state, it being within certain states, which is perfect for like dealing with subscriptions that should prolong through multiple state changes. And then you have this more low level of, I moved from this state to this state. This was the action that caused it. I want to base a side effect on that. Yeah, and this is why I'm doing this stream. Like I'm talking through all the thoughts around this. And again, you can argue that the loaded, like the add to do here, says nothing about what should happen on the outside. But that's kind of the point as well. Like, this is supposed to be, as I said, it's not supposed to be a state chart. It's not supposed to have an understanding of all the actions and effects and all that stuff that needs to happen. It only needs to deal with the state. And then it's up to the outside world to interpret the state changes and run side effects based on them. Yes. So what I thought we could do is actually look at some other examples. So let's keep this open. I don't know why I have so much. Yeah, let's look at the family scrum thing, because I looked at it there as well. Oh, the coffee gets cold fast. I wonder a bit about these cards. I think I need to get some feedback. I'm a little bit confused that some of them doesn't have like the latest information. Like it doesn't indicate when I actually opened it last time for some reason. Let's see. I think this is the one I played around with. Let's look at which version it's running. React state. Oh, this isn't the last one. Which was it? Maybe it's this one? Yeah, package JSON, React states next. Oh, 15.10. That sounds weird. This is old, right? Or is it? Yeah, no, it's not this one either. God damn. Oh, maybe I did. Did I do it locally? Okay, let's try this last one. No matter, we don't have to, we can very easily explore. Oh, I think I actually committed it. Did I do that? Let's go to the main. Like I merged it. I can't remember. No, okay. So we are going to fork this, and we're going to just look at this API and see how it's affected by it. So let's go in and say yarn and React states next. Cool. Let's open it in VS Code. Yes, trust the authors. So let's take a look at, so in the dashboard, I think we have, let's search for it. Use command. Oh, we have it in the image. Okay, so what software? For streaming? For streaming, I'm using Ecamm. What's it called? Ecamm Live. I've tried a few different things like OBS and StreamYard, which is like a web client in terms of streaming. And Ecamm Live is just, it's like professional. It costs a bit of money, but you have 4K streaming. It's just super straightforward. You can invite people just using a link. It's super awesome. In my computer, no, in terms of coding, sorry, I'm using CodeSandbox Projects, which is like at CodeSandbox where I work, we have this new product called CodeSandbox Projects, which is like development environment. It's kind of like, yeah, trying to find good ways to explain it. It is a it's cloud development environment at its core, but the way we do it is very different from others. You can think about, instead of having like typical cloud environment is the cloud gives you a computer that you can access. So it's basically just a less powerful computer in the cloud, but it's always available, right? But with CodeSandbox projects, actually every branch is a development environment in itself, which is where it starts to get interesting. Like then you can start creating experiences that you can't do locally. So that's kind of the core difference. Anyways. Oh yeah, HTML and CSS. Yeah, then I would use, for example, CodeSandbox.io. That is, there everything runs in the browser. It's super, super straightforward to get up and running. So that's like version 1 of of CodeSandbox, and CodeSandbox Projects is like when you want to take it a step further. Anyways, use transition effect. So in this case, we are, so we have these commands that we don't want anymore. So we have this thing where the reducer now tells us to capture, but we don't want it to tell us that anymore. We rather want that to be something we interpret from the outside. When do we actually need to capture? So that would be when we send the capture action and we move back into capturing. That is when we want to capture. So let's try to express that. Let's prettier. Okay, so we are going to use transition. Use transition effect. And then we're also going to use a transition effect on the capture, but we are rather going to say when we move from capturing to capturing, and the action, if action.type equals capture, then we actually want to perform the capture. So this is basically how it changes. And it does, so I explored a lot of different ways to express this with an object, even having like the action name in there. But I think it's important that these transition effects points to, like all of them points to a state change. And then it's more the metadata that decides how you want to deal with that state change, including the action. So what we're saying here is that whenever we are in capturing mode and we go back to capturing, and that action is a capture, that's the thing. Like now it doesn't make that much sense to me. Like this doesn't express very well what's happening. And what I'm wondering here is that because of just this way of interpreting state transitions, or is this how I modeled it? So it's kind of weird that when we capture, we go back into capturing. Yeah, this is VS Code. But I wouldn't worry about that. If you just want to learn programming, just go to CodeSandbox.io. It's also based on VS Code, but it's in the browser. So I would just use that to start learning. And there's tons of examples there, and a lot of documentation in the open source community related to learning coding, and also using tools. They use CodeSandbox as for examples. Yeah, so when I'm capturing and I'm calling capture, like so the point, okay, so let's go through this. So initially we try to load the image, and we might get into a loaded state, or we might get into a not found state. But no matter, you should be allowed to start a new capture. And this is like, let's move this down to make it more explicit. And even when you have captured, you should also be able to start a new capture. So that's why this is lifted up. But when we are capturing and we like hit capture, it really means that it starts the camera. No, sorry. What does it mean? It means so when you start capture, it means that it means that it shows the video. Yeah, sorry. It means that it shows the video, and when you do capture, what kind of happens then is that we took a picture, and then we wait for that picture to get ready. So you could argue very easily here that, like, what I'm trying to evaluate here is that if these transition effects that starts to kind of be a bit bland or it doesn't like express very well exactly what's happening, it could actually help you model your state better. So in this case, I could say that yeah, this is interesting. Because these are definitely different states. So this is the state where it shows the video waiting for you to tap to take the picture. When you call capture, then you're moving to a state where you actually took the picture. And then when that, yeah. And when, yeah, so, okay, this is interesting. Because when the video is running, you tap. What's happening is that you move into a state where we are waiting for the image. Like, this is nothing, this doesn't happen instantly. This is async, and it's based on this event. So we are basically awaiting capture. So it's kind of, the thing is I'm calling it capture here, which is a little bit weird. I'm calling this is more like taking the image. Anyways. So what we could say here instead is that with these dates, not found capturing, what did I call it? Awaiting capture. Yeah, so I guess we want the same data here. So this is the state of awaiting capture as const. I'm starting to realize that I don't really like the yeah, this is also interesting because you don't want, like in capturing, we're actually exposing the action of doing a capture. But when you're waiting for the image, you don't really want to do that anymore. So yeah, so this is definitely a wrong modeling of the state. Awaiting capture. Awaiting capture. Yeah. And then, so this will be captured success, and we should have captured error. Yeah, this makes a lot more sense. Okay, so that's my conclusion is that in this case, we would now just go to awaiting capture, and we wouldn't even do this. We would just go ahead and actually do the capture. And this is also what I mean about interpreting state from the machine. It's like the machine is just going into a state where it expects something to happen from the outside. It doesn't tell it what it should do. Yeah, this is such a good point. So the previous version told the outside world that go and do a capture now, right? It was a command, go capture. But in this case, we said that, okay, I'm moving into a state now where I need to get a capture if I'm going to move on from this state, which makes a lot more sense. What I don't quite like about what I've done here is, yeah, the creators pattern. It's a little bit unwieldy. Anyways, that's a different discussion. But yeah, okay, so I'm getting more and more confident that this is a good way to go. But I want to look at another example. So we're going to close this. I'm just kind of evaluating if we should do this. So yeah, by the way, what language is JSON? It's a declarative language, just like CSS and HTML. So it's very much like HTML, actually, where HTML has like XML syntax. And to put it like that, you can express the same thing with in XML and JSON. It's just different ways of expressing the same thing, but both of them are designed, as far as I know, to express data structure. So it's not like to express how to like execute things like other languages. It's to describe data, basically. It's a data format. But yeah, I'm not very good at like history and using the exact terms and and comparing things, and I'm not a very theoretical programmer. I'm very like practical, based on experience and what's practical. Anyways, okay, so we evaluated that and I like that one. And here again, like this is the thing this is the core of why I feel like an itch with this, is that we're saying we're moving from loaded to loaded. Like in the resizer example, when moving from resizing to resizing, you want to run a callback. That makes a lot of sense. But moving from loaded to loaded, that is like, why are you moving from loaded to loaded? Yeah. So loaded is maybe not the right term. Like, yeah, I'm trying to lean towards what if so I'm trying to evaluate if this pattern helps you to make things more expressive. So here we are fetching the to-dos, and then we're saying like it's loaded, but what we're doing here, it's not just loading the data. We're actually expressing a state where you can interact with the to-dos. So loaded is probably a bad term here, because you're able to like add stuff to it, and well, I don't know, loaded. Yeah, again, we'll need to look at some more examples. So let's do that. Let's move to, so in CodeSandbox, we also use this. Yeah, I don't have a science degree or computer science degree either. Yeah, as I said, likewise. Like, it takes, of course, like the way I think about coding, especially in the web world, is that it's more about it's not so much about the code itself. It's your ability to have a lot of moving parts in your head at the same time and being able to express that to other people. The coding is about communicating with other developers. It's not about communicating with the computer first and foremost. So if you're good at like having a lot of complex things in your head and being able to talk about it with other people, then you can become a really good programmer. Like there are different kinds of programmers. Like you can be a really good programmer who knows how to talk to a computer, which means that like you super optimize code. It will never run as fast as when you write it, but often that means that other developers will have a hard time understanding that code because it's designed for the computer, not for other developers to understand. And then you can be a type of developer who is really good at expressing intent in the code so that other people understand it, but the computer might not prefer that. But you shouldn't really care about the computer. You should first and foremost care about other developers. But then there's a lot of subjective meaning and opinions. But yeah, HTML, CSS, and a sprinkle of JavaScript is a really good way to start. Because it's, at the end of the day, it's about building things. And HTML and CSS, like you, on the first line of code, you build something, right? Even if it's just a web page saying hello world, that web page is at least something you can show other people. And you can change the color very easily. You can change its position. Like you feel very powerful very fast, which is important to motivate yourself. And then you can move more slowly into JavaScript. Yeah, but it takes time. Like it takes a few years to become like a proficient coder, like if you want to do it professionally. But you can create a lot of value before that. Open, let's see, CodeSandbox, CodeSandbox client. This is what I was going to look at. No, not CodeSandbox client. I'm confused. Applications, where are you? CodeSandbox applications. Let's see. Let's just look at it. So we have this features folder. We have our branch management, which we're going to split up. But related to, so we have like, yes, this is old API, but this is basically commands. So what would happen here? Yeah, so this is also an interesting example because you really want these to be explicit states. Like when you actually moved into creating the branch, that should be an explicit state. The same with created fork, the same with error. And the show waitlist shouldn't be, that should really be a state in itself. Like that's, because when you're ready and you're trying to create a branch and we don't allow you to do that, we should ideally express that as a state of like invalid, like it's not branch creation invalid or something like that. That's the state you move into. Yeah. Okay. So my conclusion is that like commands isn't the way to move. And I think this also helps explain what React States is. It's closer to a finite state machine than a state chart, though it actually supports nested states. And the way you interpret that machine is through the use transition effect. There you have enough information to create any side effect. And what it's more about in terms of making it understandable is that you actually you take advantage of having these explicit states. That's the point. So instead of, yeah, exactly. So it's kind of like you don't want to have all these explicit states, you just want to be, in this case, ready. But there's some history here, because initially it was ready with create branch, and then there was no concept of is beta user here, not even permission. You just created a branch, and then we introduced is beta user. And then since we had this old concept of transient state and now command, you are like, you lean towards that instead of thinking about, okay, I want this to create a side effect, this state change, but I don't really have any opportunities than moving into the current state or into a new state. What makes the most sense? So in this case, is beta user, it's, at least to me, it's obvious that when you try to create a branch and you're not allowed to do that, you actually move into an explicit state of being invalid. And then you have a very explicit way of dealing with that side effect. So in this case, we do want to show the waitlist, but this reducer doesn't care about the waitlist. It doesn't know about the waitlist. It just knows that if you're not a beta user, you move into an invalid state. And then from the outside, we interpret that invalid state, and we just happen to show the waitlist. Yeah. Let's look at another one. And then I want to show something else. Yeah. Can't stay inside for a long time to code. I had like when I was younger, like living at home, getting my computer, was very, very interested in that computer. There was this big worry from my parents about the time I wanted to spend in front of that computer. And I remember very quickly that I started to argue that I wasn't just playing games. I was actually like learning stuff. At that time I was actually learning HTML and CSS and JavaScript. So I was learning a skill. It's just like any other skill that you want to learn. If it's like carpeting or you want to run faster, like you have to practice. And if you want to code, you have to practice. It just happens in front of a screen instead of being with a hammer and a nail. And that argument I got through to my parents. They understood that even though they wanted me to like stay outside more and stuff like that, they understood that I was actually learning a skill. I found something that I was super motivated by. I wanted to learn more. It was just how much time I could spend on it. So I kind of interpret here that you can stay inside for a long time. I hope it's because you have like parents or someone telling you that you should be outside instead of inside in front of that screen. Yeah. But remember that you're learning a skill, a valuable skill. You're practicing. You're not like just fooling around. Let's see. Let's just let's find another example here. So yeah, I think maybe Git is a good example. Do we have any transiente? Yes. Again, we have show waitlist. Is beta user. Yeah, you're trying to commit and you're, again, this is an explicit state. You're trying to commit, but you are actually, it's actually invalid. And you could even, oh, this is interesting because we've been discussing passing these values in. So when you're a beta user, you shouldn't even be in the ready state. You should immediately go to invalid commit state. maybe. Not invalid commit, but like you're in a state where you're not allowed to do these things. It depends. It definitely depends. So it depends on what you want to happen. So if, in this case, if you didn't want the user to be able to do anything, it would make sense to put them in a state where it doesn't treat any or create any actions or handle any actions. But in this case, we actually do want you to do the action, commit in this case, but we just want to move you to a different state when that happens. So yeah, this is modeled correctly, but we want to move you to a state of having done something invalid. So it would be the same here, but we have more stuff here. We have start pull remote. Yeah, so this is also interesting. We talked about this. So yeah. So what we didn't do here initially, we didn't have substates. So in this case, this shouldn't really like put you in a pulling remote state, but we should have an explicit remote state, which is either like idle, or it's pulling remote, or it's pulling target, or if it can do both. Yeah, and what would happen here is that when you do pull remote, you would actually, yeah, this is an interesting one we should evaluate. So what would happen here is that, oh, fuck, I can't change the code. Okay, let me just fork it. Yeah, so if you, let's see. Yeah, so in terms of where I'm working, I'm currently working at CodeSandbox, which is the tool I'm using. In terms of salary, how much is it? I think like a typical salary, it depends heavily. Like I'm working, I live in Norway, but I work for a company in the Netherlands. So I'm kind of self-employed, which means I have to buy my own insurance and stuff. So that's the thing about salaries. It might sound like people have a high salary, but they don't really, because of the place they live, and they have to pay a lot of stuff on their own. So I have, if I took a job here in Norway as a consultant doing programming, I would definitely earn more than what I do now, but there's something magical of being part of a startup, and it's like it's more than enough for me. Like I don't have an ambition to have like a big house and an expensive car, even though I think about that sometimes. I know that that's not what makes me happy. It's so funny, like it's so amazing how society has put these ideas in our heads, like this culture, this global culture of having big houses, expensive cars, everything that costs a lot of money is what makes you happy. And it's so bullshit. It's complete bullshit. But you have to force yourself. Like I have the same cravings. Like we just had a conversation in the family about getting a car, and I of course wanted a specific one, which is like costs way more than what we actually need, but I have the craving. I think I'm going to be happier by having that more expensive car. But what would happen in practice is that I would be upset all the time because we had two small kids and they would like not treat that car as well as I wanted them to do. Maybe I would get a scratch on it. I would be super angry. Like yeah, anyways, I'm diverging. But in terms of salary, it's around, like, in euros, is it like 9,000 a month or something? Is it? No, that sounded a lot. 8,000 a month. Yeah, but again, I have to pay, like, but those, yeah, and that's the thing. When you ask someone how much do they earn as being employed, they tell you how much they actually get after taxes, because your employer subtracts the taxes for you. But as self-employed, you typically give your salary as the full salary. But I still have to pay taxes and, of course, insurance and everything on top of that. So when I say I earn like 8,000 euros a month, like, it's far from that. Far from that. It's half of that I actually earn after taxes and insurance and everything, which is a good salary. I'm not complaining about that at all. But yeah. Yeah, it's so interesting. Ask me all these questions. For a project like that can take forever, like never finish. But that's the thing. I would a really good way to learn coding is to look at something that has been built already by someone and then try to re-implement it. Just write the code from scratch and try to build it yourself. Don't care about it being built from before, or someone else built it before. But yeah, every project has a different length to it. And I typically lean on, I love the web, working with HTML and CSS and JavaScript especially. But yeah, to build something that matters to others as well, there's no shorter path than the web. If you're going iOS or Android, you're not going to even get started coding, I think, because the path of learning programming to actually publishing that for someone else to see it and try it, it's a lot of stuff not related to coding you have to go through. It's crazy. But not on the web. Anyways, use transition effect. State. So what we would do here is yeah, exactly. So we would say when you move from ready to ready. Oh, this is oh, yeah, wait, this isn't working. Oh, I'm so glad we met this example. So here I was thinking, so let's imagine we had like a substate here. If state state so like remote pull state equals like pulling, then you would like do the side effect. The point is, we don't know if we move from ready to ready in some, like here, like we might pull remote target, which moves you from ready to ready. And in that case, yeah, so this is interesting. Yeah, because you wouldn't express, okay, this is interesting, because you wouldn't express it this way. You wouldn't check the state, you would check the action. That's the whole point there. That's why we have the action. You would check action type equals pull remote. That's what you would do. like, even though we put you into, yeah, exactly. Yeah, so self-employed is when you send your own invoices. You're not being hired by a company. You just start to send invoices. You get your own work, and you send invoices for your work. And in Norway, that's very simple. There's a lot of web services, like from the state, that allows you to easily set up a company, easily set up invoicing and stuff like that. There's a lot of stuff to learn, though. Well, not a lot. It's very, at least in Norway, it's very simple, but you can take courses and stuff on how to deal with taxes and insurance and all that stuff. But I wouldn't, yeah. So if you have no experience or don't know anyone who's self-employed, I wouldn't start there. I would try to find a job first and then consider being self-employed later. But if you have someone who can help you, yeah. So yeah, I work from home. But in these days, a lot of people work from home, even though they have an employer. So, but that's great, working from home, especially having 2 kids. But yeah, again, I would, the thing that a lot of, like, I'm getting old now, but the thing that a lot of young people get wrong is that they think about this goal in the future. Like, as you say, you're 21 now, and you have this ambition that is like 10 years from now. But what's really important is that you can't like sit here now and think, oh, in 10 years I'm going to be happy. That's when I'm going to earn a lot of money. That's when I'm going to understand, I'm going to have learned a lot of coding. I'm going to have a great job 10 years from now. That's going to be amazing. I would try to not, like, people don't agree with this. A lot of people think it's good to have a very specific goal, like 10 years in the future. That's what you're chasing. That's what motivates you every day. But I'm in the camp where you should find something now that motivates you every day. Like, you just enjoy doing it every day without a specific goal in mind. So if you enjoy fiddling around with HTML, CSS, and JavaScript, not for that 10-year goal of earning a lot of money and being good at coding, just because you enjoy doing it every day, that will lead to something good. Like, everything that motivates you intrinsically will lead to something good. But maybe people are different there. I'm that kind of person. I just do stuff because I like it. And that has led to a lot of nice opportunities for me. Again, this is not just me, like, it's the environment I happen to have grown up in, and opportunities being handed to me unrelated to my skills, just being like, you know, what's it called? 40 and white. It's yeah, it's sad, but yeah. So and just being like outgoing, very outgoing, gives you more opportunities than if you're more like reserved, which is unfair, because there are a lot of brilliant reserved people. Anyways, my point is that if it really does motivate you every day, like, if you enjoy every day chasing your 10-year goal, please do that. But if the only thing that motivates you is to get to the 10-year goal, and it's a struggle every day to sit down with a computer and learn something, then you have to do something else. You have to find something that you enjoy doing, and it will lead to something good. You can't like decide now where am I going to be in 10 years. Nobody knows where they're going to be in 10 years. Stuff happen, opportunities present themselves, stuff you never knew would be come up. The only thing you can do as long as you live is to try to make every day something you enjoy doing. Yeah, that got really deep. Anyways, so back to our example here. So this one, now we're kind of back at this ready thing, where we are saying, I like, it's not like, the thing is that it's technical. If you're technically moving, it's the way it's expressed that's bothering me. Like, there's so many scenarios we went through now where it expresses it really, really well. But here I don't quite like it. Because what happens in the actual implementation here is that we say like state, and then you have to do this. Pull remote, stay in the same state. It doesn't really make sense. You're not expressing that you expect something to happen on the outside. You're really saying nothing should happen. And this is what I don't like. This is what I don't like. So this could have had a substate of like pull remote state pulling, for example, which makes a lot of sense. It's the same with like a file you're trying to, or you're trying to save it. You will actually put it in the saving state, the actual to do. It makes a lot of sense, but from the outside, you can't really. It's not a one-time thing. You would still have to. So yeah, this is so interesting. If state pull remote state equals pulling. So if the substate is pulling, do side effect. The problem here is that this might occur multiple times, moving from ready to ready, completely unrelated to this. So it would do the side effect multiple times. In this case, with the action, we are saying only do this side effect when you move from ready to ready due to this action, which would only make it run. Yeah, which is actually quite interesting, because if you had this pull remote state and you would call this again, you would actually check. So if state pull remote state equals idle, then you would actually update the pull remote state. And if not, you would just have the state, which means this side effect would never run. Yeah, this is something I will need to reflect on. This is something I will need to reflect on. Substates is a bit tricky, because you kind of want them to, like in state charts, they actually act as self, like it's like a sub-reducer. Which is actually quite interesting. A substate is a sub-reducer. Yeah, but that's only one level. Yeah, it's really tricky. It's super tricky. This example it's really good. I have to reflect on this because this is where it worked so well up to this point, but when it comes to substates, things get tricky, which is the reason we even had it started with transient states and then commands. It's basically you have these substates you want to deal with, which these outside transition effects can't deal with, because they only deal with the upper state, like the root state. And then, as I said, if you were to kind of go in and look at, did I change the substate to pulling, do the side effect, that won't work, because you might move to the root state again for some other reason, which would trigger the side effect again. But with the information of the action, you actually start getting somewhere. So this is interesting. So if you said action type pull remote and state, pull remote state, is pulling. So what I thought about is to actually have a matcher on this. So you would do like match transition state action, and in this case we could actually say state pull remote, and it would just say pulling, and the action is, well, idle. It will be idle, and the action will be pull remote. Then go ahead and do the side effect. Let's see, let's put it down how it would look in code. It would look something like this, but it's kind of silly to have this object for just one thing. Yeah, create anything different, that will be the future. Yeah, every change is something different. The funny thing though is that a lot of people think they need to come up with novel ideas, novel being like something new, completely unique, but most things that change the world is like, even when people talk about innovation, they think about it as something being completely novel, like nobody has thought about this before, and that's not true. Like most things, like innovation is taking two things that is unrelated to each other, like in the minds of people, and they find a way to combine it. That's what innovation is. So the perfect example for me is when Apple introduced the magnet on their power supply, or the power cord. That's actually from rice cookers. They've been doing this forever. Nobody thought about putting them on a laptop, except Apple. So that's like an example of that. So I think that's where you want to, that's one part of it. And the other part is that people think that good ideas comes from your head. Like that's how you, again, innovate and make change. But if you want to actually make change, you have to learn. So if you want to make a change in the world, go in somewhere where there's obvious improvements to be had, and learn. Why isn't this better? Why aren't we innovating here? Why aren't we doing this in a better way? And then you learn, and then you do something about it. So a lot of startups, they start with someone having this idea, like this novel idea that's going to change the world. And then it just breaks down. It wasn't such a good idea. Nobody wanted it. and so on. And then you have this other type of startup. It's just people, smart people coming together, and they're looking at the state of the world, and they're identifying somewhere where things should be better. It doesn't matter what it is, what their interests are. It's just analytically going and figuring out, this could be so much better. Why isn't it so much better? And then they go in and they learn as much as possible about that concept. And then they see if they can actually find a way to do it better. So I can't remember the book, but I read a book where they talked about, this startup team, and they actually went into the cleaning industry. Like these were young people, ambitious young people who wanted to do a startup, but they didn't have an idea. They took this analytical approach, and they discovered that like the way cleaning worked could be done so much better. I think one of them had like experiences with it, and they actually got employed at existing cleaning services to learn, like, how do existing cleaning services do their work? Where could they do things better? And then they met and they talked about this and how to make it better. And then they had like an idea based on actual experience and data, instead of just someone personally thinking they have a great idea. So that's and like Elon Musk is that way at a huge scale. Like going from a cleaning company to SpaceX and Tesla, that's a big jump. But it's the same principle. There's something that needs improvement, and then it's all about learning. It's the same with Netflix. Like like if you read the book on how Netflix came to be, how insanely analytical they were. It wasn't like someone coming up with, we should have Netflix, this streaming service. They started like, you had these stores with DVDs, and they thought, this can be done better. Like, what if people didn't have to go to the store? Maybe they could just order the DVD. And just starting by buying a bunch of DVDs and then sending it to people and trying out different subscription models. Where's the problem? And in old Netflix days, it was with most startups, it's the what's it called? Not the infrastructure, but like shipping. What's it called? There's a term for that. I can't remember it now. Oh my god, it's on the tip of my tongue. It's oh god damn it. It's when you need to move stuff around. The process of moving stuff around. So what made Netflix work back in the days with DVDs is that they actually had these small hubs around the country that received the DVDs and sent them right back out. And they actually had subscription services on DVDs, and they promised they would get the DVDs the next day even, which is kind of insane. And they even experimented with different ways of sending the DVDs so they would be sent faster. And like there's so much learning that goes into it, and it's so intentional. While a lot of ideas, they think the idea is going to drive them to success. Ideas are nothing. They're worth absolutely nothing. It's the intention of learning and changing that idea with those learnings. That's the path to success. Oh my god, we just got way deep into other stuff. Anyways, this is the thing I'm going to reflect on. Use transition effect. So yeah, let's just play around with this a little bit. Just to, as I said, let's try and learn. So what if you didn't express this with transition from, transition to? What if this this first argument is always a state, the state you're moving into? But what if the other one was like pull remote? So we're stating that we do not care about that we're moving from one state to the next. We are saying if we moved into this state by this action, that will mean we could run the pull remote immediately. Whereas this substate would be used to identify, to guard calling pull remote multiple times. So the first time you pull remote, you use that substate to move into a pulling state, which could be indicated in the UI as well. But in terms of the side effect, you just check that, okay, you moved into the ready state by pull remote. And in this case, if it was already pulling, you wouldn't actually move into, like, this is also a thing, like with reducers, when you return the same state, it doesn't reconcile, which means that it doesn't run the side effect. So it's basically a no operation. Yeah, this is interesting. How would these other ones look like? How would they look like? So we have pages, components, dashboard. Did I have? Okay, so we had this thing. Where the hell was it? No, it was an image. Where are you? Use image. Sorry. So yeah, so here we concluded that it was definitely. But we can reset this. Let's see. So let's imagine that we don't want this command, but when we are in capturing and we capture, we move back to capturing. So it would just look like this. And in this case, we would say use a transition effect, and we move into capturing, but we did so with the action capture. Yeah, this makes more sense. It's not from state to state, because you don't like, yeah, I don't think you really care about that. Okay, so that's a theory. And then we have the last example, which is React states. So again, here you would say add to do, which means you don't have to do this check. Yeah, and you could even express this as you are in loaded state and you receive add to do. Maybe we could even type that. Maybe. No, we can't type that because it's, yeah, we don't know that. So we are loaded and you add to do. And this only runs if it's actually successfully moving into the loaded state again. Like if it's successfully moved into loaded with an add to do action, then run this transition effect. What about this one? So in this case, it actually made a lot of sense to move from state to state. But what if we were to express that with an action? So what we're saying here is that if we are resizing to resizing. So what we could say here is that if we are resizing, so what this would be expressed as was mouse move. So if we move to resizing with a mouse move, we want to notify. And if we're moving to this is the thing, like, yeah. Oh, this is interesting. So if we move to idle with a mouse up resizer, then tell the outside world this is an on click. Okay. Okay, I like this. This is much better. You're just saying, if I got into this state with this action, do this thing. It does mean, as we talked about, that you might have things like, if you didn't do, like it would mean, in this case, it would just do this. So we would express that as, if you moved into ready with pull remote, then do this effect. What's kind of weird about this state is that it doesn't have an explicit substate. We're not saying that it's pulling. Yeah. Oh, okay. We do have pull in progress. Oh, that's interesting. Why doesn't it move into pull in progress? Yeah, it should. Okay, this is interesting because this should really have a state of awaiting pull. But I think this is one of the arguments. It's like, here you have awaiting commit. It should also be awaiting pull. Oh, yeah. So these are actually, yeah, they are actually modeled the wrong way. Okay, but I think I should probably stop. Should probably stop now. But yeah, this was, for me personally, just being able to talk through this helped a ton. And I do think we care more about entering states where sometimes we actually wonder, like we want to set a prerequisite of how we got into that state. And what we're seeing here is that a lot of the examples we've been looking at actually should have some more explicit states. The problem with having more explicit states is it's kind of that it's more work, which explicitness always is. But it's like, yeah, it's interesting because it's not very well guarded. Like if you pull remote, between pulling remote and pull started, you can actually call pull remote multiple times and you will actually try to pull remote multiple times. So it is actually not implemented the way it should be in terms of being guarded. Yeah. But then you can argue like, oh, I have all these states. I don't want any more states. But you need more states to be explicit. Okay. So in terms of this branch management thing that we, yeah, I think I need to do a new test refactor of that. But okay, so, well, we do have some more time actually. Oscar is still sleeping, which is awesome. Okay, let's go ahead in React states and actually change this. So I'm going to, when I work with typing, I always do that from VS Code. So what we're going to do, we're going to go to index and we're going to change our, yes, I use transition effect. So this is, yeah, so this is from to, but this is actually going to this is oh, how do we do this? Where's the exclude? I think type. I think this is how we do it. So this would be state current. Let's call that current, and then it will be the action. Let's call this SS. I think that's the term I've been using. And then this is the action. Let's call it AA. So this would be SS, and then the action would be the actual action. And type is AA. Okay, crazy stuff. So what we have to fix now, if current, so this would be, let's rename that to action. That means we don't have to check this. So this, what's different about this when we check the current state towards an action is that it will always run. Not when entering the state initially, but whenever we update that state. So here we would actually have state, and if the current state, and this is interesting because we don't actually need the previous state now, which also cleans up. Yeah, let's remove that. So if the state is current and state action dot type equals action, oh sorry, action, that's when we actually want to, and we need to do this. That's when we actually want to move into that thing. And now we can actually remove the prev state concept. Prev state. Prev. Okay, nice. Because that didn't really do anything. Yeah, I like this. This cleans it up. So what should be possible now? Oops, in the source DevTools resizer. Oh, yeah, exactly. Let's see if it actually gives the typing. Yeah, mouse move. Nice. Yeah, because this is the thing, like the outside world knows about what it shoves into the machine. But the machine decides what states you can transition. So it's kind of a validator. Whenever I have successfully moved into resizing with a mouse move, do this side effect. Or, okay, so it's like, whenever I successfully move into this state, do this thing. Whenever I successfully, well, whenever I move into this state, yeah, like it's the thing where it's not every time, but it's the, so the first time, not the first time either, it's more like, yeah, so when I am in this state, do this side effect. And then there's an extension of that, which is the array, which is when I am in these states, do this side effect. And then you have when I'm in this state caused by this action, do this side effect. That makes a lot of sense. So even with our create branch, if I remember correctly, we would say when moving into ready caused by, well, in that case, it should be an explicit state so that it should be handled differently, but we could express it as if I move into ready caused by create branch, show the waitlist. Yeah. Yes, I am happy. It's definitely an improvement. Do something. what I could do here is I could flip the action and the state, because when you say I moved into this, no, we shouldn't make that consistent. It's no biggie to do the underscore thing. Okay, so let's store this, and I'm just doing incremental changes as this is like part of the next thing. Oh, what's in the README? Yeah, let's update the values. Let's do that, and that will stop the stream. Simple utility functions and types, that's still true. Enhanced type safety, that's true. And then I was trying to express that it doesn't have any abstractions over the core primitives. No abstractions over core, but that's not true. Like use transition effect is exactly that, an abstraction over core primitives. Expressed as an enhanced reducer, well, that's true. So it should be a set of simple utility functions and types. It should do enhanced type safety, and it should be that's a core value, is that when people see React states, they are going to think about their reducer and still see a reducer when after they apply React states. It is just a reducer. Yeah, let's put that in quotes. And then finite state machine more FSM than a state charge. So it's kind of, we go in this direction. It's more a finite state machine than what it is a state chart. So it does have substates, but that's more a model of state and functionality of transitioning. Yeah, maybe this is too much. What I rather can say, side effects are purely no side effects expressed in reducer. So this might not make sense now that you can't do it, but it's an important value because certain state machines does express side effects within the machine itself, like state charts. But I don't want that here. I want this reducer to do what it does, which is manage state, and then it's to interpret those changes from the outside. Yes, that is what it's going to do. We should probably test it. Let's see. Have they fixed this now? No, is it still not fixed? Let's see. Let's test it here. Oh no, it's too big. Oh no. That's something. God damn it. Let's see. It's too big. Well, the resizer still works, so that's something. Yeah. Well, if the resizer still works, and then it works. Cool. I'm happy. Use transition with action. What I like about this as well is that the signature is that when you use transition effect, you give it the state, you give it the state, and that's always when I move to this state. That's always the same through the three signatures. And then when you introduce that second string, it means via a specific action. Cool. So I'm going to go downstairs and I'm going to publish this as next. And then I think I want to do another refactor tomorrow of maybe we can do families. Sorry, the Excalibur project. We're going to refactor the Excalibur project to use this new use transition effect. Yes, maybe that's enough. Maybe that's enough. Yeah, also, I couldn't help myself. I built a new library. No, it's not a new, nothing to publish. I was just thinking about, with all the learnings from React states, which at its core is the use reducer, or maybe that should be one of the values. Like it's based on, what the hell's happening here? It's based on the use reducer of React. Well, this is actually something else. This is actually taking those learnings. Oh wait, this is old. And thinking about it as its own thing. So, oh, this looks super messy. Where do we have the actual? Okay, so this is the actual code. So I was thinking about the concept where, what if you didn't have to do all this typing? What if we could just infer everything? So when you rather use functions, so it's more functional than typal. So these states, you create these states with a function. So these are like state creators, but what you see here is that we actually return, we add the property for you. You don't actually explicitly type them. You just create the states, and then you create a machine, and through this machine, let's just comment this out. Through this machine, you just start defining the states, and what this means is that you can define substates this way as well, which is nice. And then what you do is that you define the action. So you don't have to type the actions, you just write them. And then it's kind of like if you use Redux, it's kind of the first here is the arguments for the action, and then you have the current state, and then you produce the new state. And now you produce state by calling these functions, which gives additional type safety. But what's really cool about this is, so here I have the state foo and bar, and if I go to actions, I have switch. Now, if I were to introduce a number here, and I go to actions.switch, suddenly it requires a number. So I don't have to type the state and the actions explicitly. I can just implement the machine, and then I get that typing for free, which is amazeballs. And what it can also do is that I can use transition effect, and then it already knows about the states. Like this isn't done, but I would actually get the states automatically here. It will all just work out of the box. So you wouldn't have to like pass it the state and stuff. It's just part of the machine itself, which is pretty awesome. So this is not using like under the hood, it's using a reducer. Does it even use a reducer? Can't even remember. No, that's the point, sorry. So this thing is agnostic. It's just a JavaScript library, and then I just added it doesn't use a reducer at all, but I added like hooks for React to consume the machine. But you wouldn't have to do that. You could just create a machine, and you could manually like subscribe to changes and call actions on it. You wouldn't need React. That's the point. But it's super, like, I'm thought about just calling it Tiny Machine because it's such a simple concept. It's giving the exact same values as we learned through all of React states, but it's library agnostic, and you don't have to do the typing. So I thought I would play around with this some more as well. I'm going to, now that we settle on the use transition effect, I'm going to make it work the same way here. So I'm going to wrap this up into a kind of a repo and play around with it. Yeah, because I really like focusing on, especially with explicit states, it's like you think about the states and not the typing as much, which makes sense to me. Anyways, so I have to go and wake up the little one. He's been sleeping nicely now for almost 2 hours, which is, we're getting back to normal. That's good. But yeah, thanks for following along, and thanks for all the questions unknown. Good luck with setting goals and getting the time to practice. Just make sure that you enjoy practice. That's important. And yeah, sorry for going all philosophical, but I have a lot of thoughts around life and meaning and all this stuff. So that's what you get. Anyways, thanks a bunch for following. And this was super helpful for me, aligning myself on some thoughts. So this is